Hello colleagues, my name is Phoenix and this is the 6th episode of my SKSE modding tutorial series. In this and the next videos I will talk about hooks. To develop plugins on SKSE, you need to be able to do two things. Find a suitable place for the hook, aka RE, and write the code of the new function. A hook is a way to intercept the flow of program execution and run your code. Today I will tell you about one of the three simplest methods of hooks, the virtual function hook. In the next videos I will talk about the function call hook, the hook at the beginning of the function code, and a more complex method, a hook in the middle of the function, as well as about callback. Finding a spot for a hook is the most important part of plugin development. Each developer has their own goals and needs, so everyone is looking for their own place for a hook. I think I spend 80% of my time looking for a place to hook, 10% of writing code, and 10% on testing. But there are some functions that are often used for hooks, such as onHit or player update. I have some tips for finding such functions. I will share them after this topic. In this video, we will not do RE. I will just give you the addresses of the functions that we will hook. To get control in the plugin from anywhere in the game, it's enough to change the bytes of the program so that the program jumps into the DLL. But there is one problem. It's impossible to do this just by GMP command, so do this. Instead of the gz command, for example, you write move command. It writes address of the plugin code to the rex register. This is the address of the code in your DLL that is loaded in the memory. But this approach has its own difficulties. For example, returning back to the program code, clearing the stack alignment, volatile registers. Fortunately, there are several life hacks that allow you to avoid these difficulties, but they are not always applicable. Sometimes you need to make a hook in such a place or in such a way that these methods are not suitable. For example, you need to get a value from a register that is not passed to the function when called. Or you need to make a hook in the middle of a function that is not virtual. In such cases, these methods do not help. But they are very easy to use. You can make a hook in a few lines of code without knowing the assembly. You can copy the hook code from your old project and change only the address and the name of a function, and everything will work. These methods are also good in terms of plugin compatibility. If several plugins make a hook in one place, then most likely they not conflict and not cause CTD. This is not the case if the plugin changes the assembly code or makes a hook in the middle of a function. Therefore, most of the hooks in my plugins, and I think in the plugins of other developers, are the use of these three methods. And of these, the most popular is the function call hook. I recommend that you first look for a hook location that is suitable for one of these methods, and only if there is no such place, then use other methods. In the next video I will tell you what to do if there is no such place and how to deal with the difficulties I have described. Now let's look at these three methods. I'll tell you when and how to use them, then I'll show you how to make a hook naive way so that you understand what's going on inside. Then I will give some examples of hooks. The first way is to hook a virtual function. To do this, you need to know what virtual functions are, how they work, and how they are implemented by the compiler. If you don't know this topic, I advise you to study it, but I'll explain briefly now. Virtual functions are needed in order to call a function that corresponds to the dynamic type of an object, not the static type of a variable. A static type is what you specify when declaring a variable. A dynamic type is the type of an object that lies on the pointer or reference. Static and dynamic types may match or differ. They match if the variable is not a reference or a pointer. So the variable base and derived have static types the same as dynamic ones. They differ if the variable is a reference or pointer to the base class, and the object pointed by the variable is a derived class. The variables base1 and derives1 have a static type base reference, since it's specified when declaring the variable. What is stored in the base reference type variable? Maybe a reference to base, maybe a reference to derived, maybe a reference to any descendant of a base. Therefore, the dynamic type for base 1 is the same, and for the derived one, derived reference. If the variable is not a reference or pointer, then the function is called by the type of the variable. Look, in both cases, a function is called from the desired class. But what if you want to store pointers to different objects in the same array and run through it by calling a function corresponding to the type of object that is actually in the array? In the case of regular functions, this not works. Both variables of the same type are pointers to the base class, and regular functions are called according to the static type. Therefore, in both cases, foo of the base class is called. To fix this, you need to make the function virtual in the base class and override it in the derived class. A class that has at least one virtual function is called polymorphic. Virtual functions are called by object type. Don't pay attention to the fact that Visual Studio highlights the wrong function. Polymorphism is implemented through a virtual function table. Each polymorphic class contains a hidden field which is appointed to this table. The table stores the addresses of all the virtual functions of the class, including functions inherited from base classes. The order of functions in the table is determined by the order of their declaration. The structure of a class looks like this. First comes the pointer to virtual function table, then the rest of the fields. The size of the class must be a multiple of 8 bytes, since the pointer takes up 8 bytes. Also, 8 bytes are added to the size of the class without virtual functions. In the case of the base class, its table has 2 functions, as the class has 2 virtual functions. Due to the pointer to the table, the size of the base class is hex 10. The derived class looks similarly. First comes the pointer to the table, then the fields. They are arranged exactly as with regular inheritance. The size of the class should now be clear. The derived class contains 3 virtual functions. A new virtual function has appeared, one of them has been overridden. The foo function is not overridden, so the pointer still points to the function from the base class. And like base and derived classes, instances of which can be created in many quantities, base vftable and derived vftable classes are present only in one instance in a binary file. Now let's see how it looks in IDA. Go to the CombatBehaviorThread update function, which has already been reversed by me, so this function may look different for you. Just look how a virtual function calls look in IDA. There is a polymorphic class node. The first field is a pointer to the table. Here is the table. Here are the function calls. In assembly it looks like this. RSI contains a pointer to an object of type node. This instruction reads the first field into the rex register, which is pointed to the table. This instruction initializes the this argument of the node class function, because R6 is the first argument of a function. This instruction calls the function. First, a read occurs at address rex plus hex 10, and then the read address is called. Since rex points to the beginning of the table, i.e. to the first function in the table, rex plus hex 10 points to the third function in the table. Yes, it's enter. So this instruction reads the value of the pointer to this function and call it. This is what the table looks like in IDA memory. Here is its name. It's used in constructors and deconstructors. Then each line contains a pointer to a function. For example, in this table, the node object base class overrides all functions except getName and enter. The node object class inherits from it and overrides enter and destructor. All virtual function tables can be found in the offsets vftable file in CommonLib. If a class inherits from several polymorphic classes at once, it contains several pointers to tables. They are arranged as if they were ordinary fields of by classes with multiple inheritance. Therefore, this file contains an array of IDs, not just IDs. This method is based on replacing a pointer to virtual function with a pointer to function in your code. If function signatures match, your code works, and control returns to the instruction after calling the virtual function, as if a regular virtual function call had occurred. You can do this with any virtual function and your code executes every time this function executes. In addition to your code, you can also use the original function. You can call it with modified parameters or change its return value. The advantage of this method is that it does not require RE, as most addresses and signatures of virtual functions can be found in CommonLib. However, there are disadvantages too. The first one, the number of virtual functions in code is limited, which limits your possibilities. The second one, you cannot know all places where this function is called, as X references in IDA does not work for virtual functions. Now let's look at few examples of using virtual function hook. The projectile class has a virtual function getGravity, which is used to calculate the trajectory. The goal is to make the Overdraw Perk of the last rank make arrows independent of gravity. To do this, replace the getGravity function of the arrow projectile class as a class of projectile, so that it returns 0 if the archer has this perk and the original value otherwise. First, write an implementation of the getGravity function. Its signature should match the original. It takes a projectile and returns a float. First, get the archer. The presence of a perk is checked using the highspec function of the class actor. Since the archer can be a trap, just as object refer, you need to perform type casting using the is function and cut off the trap case. The perk is obtained using the lookupById function of the testForm class. This is just an example code, and it's not recommended to look up a form by ID every time a function is called in your plugin. This will be discussed in future videos, so don't worry about it for now. So, if both checks are successful, return 0. In all other cases, return the original value. First, return 10 and see what happens. Next, write code for the hook. Projectile inherits from testObjectRefer, which in turn inherits from several polymorphic classes, so there are several values in the array. Since the function is added by the projectile class, it's in the first table. If you hook a function that belongs to a class from the second place in multiple inheritance list, you will need to use the next element of the array. First, you get the address of the table. If you add to this address the number of functions multiplied by 8, you get the address of the function in the table. In IDA it looks like this. Before adding, pointer equals runtime address of this place. Each addition of 8 moves address one line down. Since function number is bt5 in hex, you need to move that many lines down. Using saveWrite function, you replace old pointer to getGravity function with new one. Now, in all places where getGravity function is polymorphically called and dynamic type of projectile is an arrow, not beam, fireball, shot, etc., your plugin's function will be called. Check the result. Without the perk, the arrow flies with gravity 10. With the perk exactly straight. Now, it's necessary to ensure that the default value is returned on failed checks. Calling the function using the first argument leads to recursion. Therefore, it's better to call the function directly. Now a shot without a perk happens normally, and a shot with a perk always flies in a straight line, regardless of force. Note that this works by default for all actors, i.e. for both player and NPC. If you want to leave this ability only for player, you just need to add one more check. In most cases, adding functions working for everyone via Papyrus requires many actions and leads to safe bloating. This implementation is almost perfect, but there is one problem: compatibility. What if two mods want to change arrow gravity? One checks for a perk, the other for a bow enchantment. Since plugins load in alphabetical order, changes from the first plugin will be erased by the savewrite function from the second plugin. The solution to this problem is to save the old value of the function pointer. Initially it's point to a function from the game, but after the first hook it will point somewhere else. You need to use this pointer instead of calling the function directly. Now let's discuss compatibility. This mainly applies to virtual function hook and function call hook. Consider two plugins and serial options for what behavior they want to bring into the game. Situation 1. The first plugin nullifies gravity when the perk is taken, and the second one does so when there is an enchantment on the bow. Situation 2. The first plugin halves gravity when a perk is taken, and the second one nullifies it when there is an enchantment. Situation 3. The first plugin halves gravity when a perk is taken, and the second one reduces it by 5 when there is an enchantment. What do you think? In which of these three situations are plugin compatible? The archer can have both a perk and an enchantment at the same time. That is, there may be a situation where both modes want to change gravity. In the first situation, plugins have consensus. They have one goal. They are compatible. In the second situation, plugins have different goals but one result. Gravity equals 0 and both plugins agree with each other. They are compatible. Let's look at an example from the first situation in more detail. Suppose that gravity without plugins equals 20. Then the first plugin reduces it to 10, and the second one to 5. If load order is different, i.e. second plugin runs first, then from 20 it becomes 15, and from 15, 7 with half. Different results are obtained. Plugins argue. They are incompatible. Moreover, suppose that gravity is always between 6 and 10. Then author's second plugin might want to make gravity between 1 and 5. It decreases but remains positive, which makes sense. What if the gravity initially equal to 6, the first plugin reduces to 3, and then by second one to -2? What if then, when calculating trajectory, square root of gravity is taken? You get CTD. Believe me, very few users could even understand that problem occurs exactly under these conditions, and just write to one of authors. I had CTD, I turned off your mode and CTD disappeared. It will be difficult to detect this incompatibility. The example with a gravity hook is an example of how the return value of a function can be changed. It's also possible to change the arguments of function itself by calling the original function and passing different values. The story about compatibility works in this situation too. There are plugins that are compatible by their nature, for example, those that only multiply, divide, or add, subtract arguments and return values. Or those whose conditions are mutually exclusive, For example, one triggers when perk is present and another when it's absent. But there are also those that are not compatible. For example, plugins whose load order can lead to different results, or plugins for which there is a load order, at which the result of plugin's work can lead to illogical results. Let's consider an example with a simple update function. It takes the amount of elapsed time, and performs its calculations. Two plugins also want to update along with this update function, so they use a hook for this virtual function. A question about compatibility arises. It seems there are no problems. First, the original update is executed, then the update from the first plugin, and then from the second. Probably, these three functions can be executed in any order and the result will be the same. If it's important for a plugin that its update is called before the original one, it can control this. Now let's combine examples. There is a simple getGravity function. Your plugin wants to completely rewrite its functionality to its own, i.e. the original value is never used. Question: should the original function be called? If you want to create compatible plugins, then yes, even if the return value is not used. Of course, if the first plugin completely rewrites Gravity, and the second simply doubles it, then the result of work depends on the load order. Neither of the two plugins can fix this on their own, regardless of where it calls the original function in its code. Okay, now the second situation. The second plugin uses the function only because it's called in places convenient for the author. It uses it as an update, just executes its code, then returns the result of the original function without changing either arguments or result. Logically, it's compatible with your plugin, but you erase its hook and don't call it. Therefore, I recommend always calling the original function if it makes sense, even if it seems very small and useless at first glance. Let's summarize. There are plugins that are incompatible by their nature. Nothing can be done with them, these plugins need to be thought about and combined individually. First, I ideologically resolve all conflicts then in code. If plugins lead to one and same logical result regardless of load order, they are compatible. If a plugin changes assembly or has a hook different from virtual function hook and function call hook, it's incompatible with another plugin affecting the same place in code. Except for several popular hook addresses, most addresses are used by only one and rarely two plugins. The file is large, unfortunately there are very few SKSE authors. Each finds their address they need and uses it for a hook. They usually don't intersect. When using a hook, remember following things. Before using a hook, make sure you fully understand how the function works and when it's called. Minimize amount of changes you make to the game code. The fewer changes you make, the less likely conflicts with other plugins will occur. Make sure that the hook handles all possible arguments correctly. Often null pater or refer can be passed instead of actor, as you might think. Call the original function as it's potentially a pointer to the code of another plugin. If it doesn't break the logic of your plugin, of course. Don't forget that other plugins may call your code as their original function. Try to write code so that your plugin is compatible with other logically compatible plugins. Now I will demonstrate a pattern to follow when using a virtual function hook. To avoid storing function and pointer to the original function in the global namespace, create a class with static functions and fields. Define a function that will be called instead of the original one. Define a pointer to the original function. In the hook function, get the ID of the virtual table, create an object rel relocation of incompatibility, then replace the virtual function in the table using the write vfunc function. The first argument is the function number, the second is the function to replace. The return value is a pointer to the original function. To launch the hook, use the hook function of the class. This way, you can reuse this code multiple times. You only need to change the virtual table, function number, code of the called function, and class name. Don't forget to activate the hook. I regularly forget this and wonder why nothing works. As you probably already guessed, you can write any code in the function. For example, you can make gravity change more interesting for players. Check perk rank and gradually decrease gravity as new perk ranks are obtained. Now I will show you what it looks like during execution. Go to the address of the function. All pointers lead to the game file and this pointer to my DLL. Now I will show you a few more examples of using virtual function hooks. The most popular place for using a hook is player update. This function called very often and has a float type parameter, the amount of time since the last update. This function hook allows executing code every frame. For example, making the player spend stamina when drawing a bowstring involves checking every frame whether the player is drawing the bowstring and decreasing their stamina. Check for player state. For this, the restore actor value function is used. 10 times the time is 10 stamina per second. This implementation might not be the best, it doesn't account for recovery. In the game, either stamina recovery or its drain occurs simultaneously. In this case, any stamina damage immediately gets compensated by recovery, which isn't disabled. Therefore, the result might not be as expected. For 5 seconds of bowstring tension, the player loses less stamina than 50. Calculating the exact amount of recoverable stamina to increase drain by this amount can be challenging. Therefore, it's recommended to find the place of stamina recovery and disable it at the right moments. If you are just starting an SKSE journey, this is already a success. Such implementation cannot be compared with a papyrus implementation. Now let's make the player lose health when swimming. The code will hardly differ. Change the check and actor value. It would be cool to distinguish different types of water and make poisoned water, but that might not be possible. Making all water poison in a specific location and comparing the location where the player is located can be an option. In such a case, comparing the player's coordinate with the water level in a given location might help determine if the player is in water. To implement this for NPC, hook the character update function in the same way. Note that the effect takes place instantly, no delays exist. I was playing a heavily loaded mod pack where there was a big script delay, so I got the effect after a second after the end of tension or jump. Let's make the projectile reflect off obstacles instead of colliding with them. Hook projectile handle hits function. It only requires changing the speed to opposite and returning false. The first is for the action, and the second indicates that there was no actual collision. There is no need to call the original function, as it processes a collision that doesn't actually exist, right? Let's check. Everything is as desired. This is an example of using a hook, not a mod for reflection projectile. Of course, it's worth finding out the normal of the surface at the point of impact and making the reflection more realistic. Also, this projectile still belongs to me, so it won't damage me. This can also be fixed. If you go further, you can find out who the projectile hit, check some condition, enchanted armor worn, whether it hits with a sword, etc., and depending on them, get different behavior of projectiles when hitting. In this example, I will tell you how to track animation events. Every time I try to implement something complex based on listening to events, I run into problems. Some animations had unexpected events for me and didn't have those events that I needed. Different order of events is also painful. Animation mode authors can even change events, delete old ones and add new ones. Therefore, I don't use them for complex logic and look for hooks whose call I see in IDA and can control. However, this knowledge is still useful and definitely can be used in simple cases. I want to make it so that when swinging a sword, a fireball is released. To do this, you need to catch the weapon swing event and cast a projectile. Unlike other events, animation events need to be caught using a process event virtual function hook. It is located in event sync animation graph event class. This class has a virtual destructor and process event function. Since player inherits from character, which inherits from actor, which inherits from object refer, and as well as testForm and handleRef object polymorphic, then the event sync table will be in the third place in the array of virtual tables. To get the actor, you need to read the value of holder and perform constcast. For some reason it's constant. You could also subtract hex 30 bytes from this parameter and cast it to player character pointer, but let's leave this method to real hackers. Find the fireball spell, then use a very convenient launch spell function for launch. The tag field contains the name of the event. It needs to be compatible with weapons weak. Let's check. Now let's make a leg injury. An actor is staggered when tries to run. Catch footprint right and footprint left events and stagger an actor. That's it. Today you learned that you can run any code together with calling a virtual function. Use the pattern I showed, it's very convenient. You can find virtual tables and function signatures in common lib. Choose the correct table number in the array with class virtual tables. When you write the signature of the function, don't forget about the implicit parameter this. Keep track of the compatibility of plugins with each other, save and call the original function whenever possible. Play C++, Hook Skyrim. See you in the next videos.